For our last problem, I wanted to show you what you would do if we happen to be written in rational exponent form instead of radical form. It's much easier to deal with these when they're in radical form, so just use the rational exponent property to immediately convert everything to a radical. So remember that our exponent property says that the numerator is the power on x, the denominator is the root. So x to the 1/3 is the third root of x to the first power. We don't normally write the 1, so this could be rewritten simply as the third root of x. We can do the same thing to our g of x. We have a 1/3 as a fraction in front. That can stay the same, but this x raised to the 1/3 power is going to become a radical third root of x. And then notice that we have a -6 tacked onto the end. So now that we've written it in radical form, let's talk about our transformations. So I see two things. I see a 1/3 out in front multiplied by my radical, and I see that I'm subtracting 6. Both of those have to be vertical because they occur outside of the radical. The only thing inside the radical is x, which has not been transformed underneath the radical. So we're going to have, with this 1/3, a vertical shrink by 1/3. And then with this -6 tacked onto the end, that's also going to be vertical because it's outside of the radical, and it is a vertical translation down by 6 since it's a negative. So let's go ahead, plot our parent function like we have before, and then our transformed function. So parent function in purple, and I'm just going to plot the points that I've done before. Okay, I've drawn my parent function f. Now let's talk about g. Now g has been vertically shrunk by 1/3, so it means it's getting further from the vertical axis. It's going to be becoming more horizontal, getting closer to that horizontal line. And I've translated down by 6. For g of x, doing an xy chart, I haven't moved left or right, so I'm going to go ahead and start out with an x value of 0 and see what y is going to be. So if I put a 0 here, this entire thing will be 0, and I've got a -6. Well, that makes sense because I said that I translated down by 6. I will tell you that the very next point that is going to give me a nice even number for y is a big one, and it's going to be way off of our graph. It's going to be an x value of 27. Let me show you why. I need to be able to divide by 3. So in order to be able to divide by 3 evenly, I need this to be a 3. What is a perfect cube that will give me a cubed root of 3? Well, that's going to be 27. So x has to be 27 to make this part, the radical, a 3, so that I can take 3 divided by 3 and get a 1. So when I get a 1 for this term and subtract 6, that's going to put me down at -5. I can do something similar with a -27. Not that it's going to do me any good for graphing when that only goes from -10 to +10, but just so you can get an idea of how flat this is. At a x value of -27, we will be at a y value of -7. So let's just do our best here. We know for sure that this point, -6, is here, and that we need to draw this super, super flat. So flatter than this is, but again, that's going to be kind of hard to show on a graph, but we can just kind of barely change above and below that 6 and call that good and say that that's g. Remember that for cubed root functions, our domain and range never change. So even though we've moved down and we've skinnied it up a lot and it almost looks like a horizontal line, it is ever so slowly heading towards positive and negative infinity in the y direction as well. So our domain and our range are all real numbers.